In this video, we're going to be talking about equivalent fractions and decimals. Generally, when you're talking about fractions, you can think of them as part over whole, or you can think of that as part divided by whole. So let's take a look at these examples. In this picture here, I have a rectangle that is divided up into 4 pieces. So the whole would be 4 because that's the total number of pieces that the rectangle is divided up into. And you can see that I've colored in 2 pieces green, so that would be my part. So this picture we would represent as a fraction of 2 over 4. Looking over here, I've taken this same rectangle and I've divided it only into 2 boxes. So here our whole would be 2, and I've shaded in 1 piece. So our fraction would be 1/2. Now let's take a look at this circle. I have divided this circle into 4 pieces, so that's my whole, and I shaded in only 1 of those pieces. And then this final circle here, you can see I've shaded in 2 pieces, but the entire circle is divided into 8 different pieces, so 2 over 8. Now what you might notice is these 2 rectangles here are the same size, and the colored in portion is also the same size. So 2 over 4, or 2/4, and 1/2, they're equal to one another. And we say that they're in the same family of fractions if they're equal to one another. You can see that in order to go from one fraction to another, if you're going from 1/2 to 2/4, I multiply this number by 2, and I multiply this number by 2. We like to say that this fraction here is in lowest terms because we can't divide the numerator and the denominator by anything to get smaller numbers. 2 over 4, we could divide both of these by 2 to get 1/2. And we have the same situation down here. 1/4 is equal to 2/8. These are equivalent fractions, or they're in the same family of fractions, but this is the fraction represented in lowest terms. Now we're going to look at finding equivalent fractions. So if fractions are equivalent, that means that they are equal, or that you can think of it as them being in the same family. So we're looking for 3 other fractions that are in the family of the fraction 1 over 3, or 1/3. So the way we want to do this is we want to multiply this fraction by something in order to get another fraction. So if you have 1/3 of something, that is the same thing as having 2 over 6 of something. And the way that I go from 1/3 to 2 over 6 is I multiply the 1 by a 2, and I multiply the 3 by a 2 in order to get 6. So this would be the first fraction that is in the same family as 1/3, or is equivalent to 1/3. I multiplied 1/3 by 2 over 2. And if you reduce 2 over 2, that equals 1. And whenever you are multiplying or dividing something by 1, it doesn't change the number. So for example, if you took the number 4 and you wanted to multiply it by 1, you're just going to get 4 out. If you took the number 7 and you multiplied it by 1, you're going to get 7. And then same thing is true for division. If you take the number 4, divide it by 1, you're going to get 4. So we have the fraction 1/3. We don't want to change what the fraction is. We still want it to be equal to 1/3, but we want it to be an equivalent fraction, so not in lowest terms. This one is in lowest terms, or it's reduced. This one is not reduced. And the way we do that is by multiplying by 1. So we could have multiplied by 2 over 2, which 2 divided by 2 is 1. We could multiply by 3 over 3, so 3 over 9. Or we could multiply by 4 over 4. So 1 times 4 is 4, 3 times 4 is 12. We can keep going, but this question is asking for 3 fractions. So 2 over 6, 3 over 9, and 4 over 12 would all be fractions equivalent to 1/3. For this next example, it's into an equivalent fraction, so we're looking for a fraction equal to 3/8 whose numerator is 15. So the numerator, what that is it's the top of the fraction. And then the bottom of the fraction is called the denominator. So we want to get a fraction whose numerator is 15. The way you want to approach this is you want to think about, what do I have to multiply 3 by in order to get 15? So 3 times 5 is 15. And then whatever you multiply your numerator by, you're going to multiply your denominator by that as well. Because essentially what you're doing is you're multiplying by 1. 5 over 5, or 5 divided by 5 is 1. So it doesn't change this fraction anyway. All right, so if I multiply by a denominator of 8 by 5, I get 40. So this would be our equivalent fraction whose numerator is 15. For this next example, we're asked to reduce a fraction to lowest terms. So we have the fraction 6 over 10, but we can reduce that and make these numbers smaller. And the way that you want to approach this is by doing prime factorization of both your numerator and your denominator. 6 can be written as 2 times 3. 10 can be rewritten as 2 times 5. Once you've done the prime factorization of your top and your bottom, what you want to do is see, what do they have in common? They both have a 2. So I'm going to cross those out, and I'm going to write what is left over, 3 over 5. So this would be our fraction in lowest terms. And oftentimes when you're working problems dealing with fractions, it will be wanted that your answer is in lowest terms. So this is something that you're going to do often. Let's try one that has slightly larger numbers. So we're going to do the prime factorization. 70 breaks into 7 times 10. 7's prime. 10 breaks into 2 times 5. Those are both prime. So our numerator is 2 times 5 times 7. 525 breaks into, and there's different ways you could break it up, but I just did 25 and 21. Um, 25 is not prime. It can be broken up. So 25 can be broken into 5 times 5. And then 21 can be broken into 3 times 7. And those are all prime. So our denominator is 3 times 5 times 5 times 7. Then what you want to do is you want to cancel out what do they have in common. So there's a 7 in both the numerator and denominator. We can cancel that. There's a 5 in both the numerator and denominator. We can cancel that. And then we're going to write what's left over. Now, you wouldn't write your final answer quite like this. You want to simplify. So the bottom, the denominator, it says 3 times 5. I'm going to actually write that out as 15. And this would be our fraction in lowest terms. Okay, So this next example, we're looking at fractions and we want to change them to whole or mixed numbers. So when we're talking about a whole number, what we mean is it's 0, it's 1, it's 2, it's 3, etc. A mixed number would be something like this, 3.5. So it has a whole part and then it has a fraction part. 10 and 8/9. Those would be example of mixed numbers. What we have here are what are called improper fractions. And oftentimes when you're dealing with an improper fraction, you're going to want to change it into a whole or mixed number. All that an improper fraction means is it's greater than 1. So your numerator is larger than your denominator. So if we are going to change this into a whole or mixed number, all we have to do is division. 21 over 3, that means 21 divided by 3. So I'm going to rewrite this like this. And we see that 3 goes into 21 7 times. 7 times 3 is 21 with no remainder. So 21 over 3 would be a whole number of 7. Now let's look at 18 over 5. That is the same thing as 18 divided by 5. 5 goes into 18 3 times. 3 times 5 is 15. 18 minus 15 is 3. So our answer is 3 remainder 3. But we're not going to write it like that. We're going to write it as 3, the whole number part. So that's this 3 here. And then instead of saying we have 3 parts left over, we're going to say 3 over 5, 3 3/5. And this would be a mixed number. This next question sounds a little strange at first. It almost sounds like there's something missing from the question. Change 7 to 4ths is all it says. So whenever you have a whole number, you can still think of it as a fraction. Just put it over 1. So just make your denominator 1. And that doesn't change anything about the number. So if we're changing to 4ths, what that is saying is we want our denominator, the bottom of our fraction, to be a 4. So we need to ask ourselves, what are we multiplying 1 by to get 4? Well, 4. And then whatever we do to the bottom, we need to do to the top. So 7 times 4 is 28. So 28 over 4, or 28/4, represents the number 7. Next example, we want to change this number, it's a mixed number right now, into an improper fraction. And remember, an improper fraction, what that means is it represents a number greater than 1, or the numerator, the top of your fraction, is going to be larger than the bottom or denominator of your fraction. I'm going to show you sort of a longer way to do this first, and then I'll show you a shortcut in just a minute. So this number, 8 4/5, you can think of this as being the same thing as 8 plus 4 over 5. It means the same thing. Just like if you had the number 4, that's the same thing as 3 plus 1. I'm just breaking it up into 2 pieces. Additionally, we just said that if we have a whole number, we can always put it over 1 to make it into a fraction. And if you want to add fractions together, the important thing is you need to make sure your denominator is the same. And there's different ways to approach getting the denominator the same, but for now what I would say is just make the smaller one bigger. So this denominator is a 1, we want it to be a 5. So I'm going to take 8 over 1 and I'm going to multiply it by 5 over 5. So 8 times 5 is 40. 1 times 5 is 5. So I'm going to replace that here. Instead of 8 over 1, I'm going to write 40 over 5. And then we're adding that to 4/5. Once you have the same denominator, it's easy. You just add your numerators together. So 44 over 5. This is kind of the long way. The shortcut is doing this exact same thing, but it's just a faster way to think about it. So with the shortcut, what you do is you take your whole number, 8, and you multiply it by your denominator, 5, and then you add that to your numerator, 4. And when you do that, you get 8 times 5, that's 40, plus 4 is 44. And you put that over your original denominator to get your answer. So you see, we get to the same place. This is just a little bit faster. But again, you're using this principle here. This principle here is why this shortcut works. All right, now we're going to look at decimals. And we're going to write these decimals as a fraction or a mixed number. So when you see a decimal and then there is one place value here, this is the 10th place value. It's telling you how many out of 10. So if you see that your number has one decimal place, you automatically know that your denominator is going to be a 10. It's going to be something out of 10. And specifically for this problem, it is 6 out of 10. Now, one thing that you'll want to check for is your fraction in lowest terms? And I see that both of these are divisible by 2. So instead of 6 over 10, I'm going to write 3 over 5, or 3/5 as my answer. For our next example, we are going not just to the 10th place, not just to the 100th place, but we're going to the 1000th place. So this is telling us we are figuring out a fraction out of 1,000. And specifically for our example, we have 51 out of 1,000. And we can't simplify that any further. That's in lowest terms. All right, our last example, we have a number here before the decimal place. So for right now, we're just going to ignore that number and just deal with the decimal place. It is out to the hundredths. So that means we're dealing with a fraction that's out of 100. And how many out of 100? 25. And we're going to add the 3 to that. Now 25 out of 100, we can reduce that to 1/4. And when we're writing a mixed number, we don't write 3 plus 1/4. Just like when we're writing the number 8, we don't really write 6 plus 2. You could, it means 8. But when we're writing a mixed number, we just do this. All right, next example, we want to change these following fractions into a decimal equivalent. So we're kind of going the opposite way of the previous example. Remember that 5 over 8, or 5/8, means 5 divided by 8. So we're going to do 5 divided by 8. And you'll see 8 is greater than 5. It doesn't go into 5 even once. So when you have that issue, what you can do is just write 5.0. And that really doesn't change the number. So now we can think about how many times does 8 go into not 5, but 50. I know that 8 times 8 is 64, so that'd be too much. 8 times 7 would be 56. That's still too much. So 8 times 6, that's 48. Now I put the decimal here, I'm going to put it here. 6 times 8, 48. Do a subtraction, we have 2. We have the same problem. 8 isn't going to go into 2 even once, so I'm going to add another 0 and bring that down. How many times does 8 go into 20? Well, it goes into 20 2 times. Two times 8 is 16. 20 minus 16 is 4. Same problem, so I'm going to add another 0, bring it down. 8 goes into 40 5 times. And 5 times 8 is 40. And we're left with no remainder. So 5/8 is 0.625. Let's look at our second example, 2/3, or 2 divided by 3. We have the same issue. We need to add a 0. 3 goes into 20 6 times. 6 times 3 is 18. 20 minus 18 is 2. Bring down another 0. 3 is going to go into 20, we just said, 6 times. 6 times 3 is 18. Subtract, we get a 2. You can see a pattern starting to emerge here. That's going to go in 6 times. We have 18. We'll just do it one more time. 3 is going to go into 26 times. And so on and so on and so on. It goes on forever. So what we have here is a repeating decimal. And there's a few ways to report this. You could write your answer like this, just showing that it goes on forever. Probably more commonly is you write a bar over the number that repeats. So this is telling us it's 6 going on forever. It's not just 0.6 as our answer. Or we could round. And this is probably the most common situation. A problem will ask you to round your answer if necessary to a certain number of decimal places. So let's say we're asked to round to the thousandths place. So here's tenths, here's hundredths, here's thousandths. We want to round here. We need to look at this next number. We see it's 5 or greater, so we're going to round this number up. All right, our next one, we have 3 3/4. Well, 3 3/4, it's a mixed number. We can break it up like this and deal with the whole number part and the fraction part separately. 3/4, if we were to do the division, we would see that equals 0.75. So instead of writing the fraction 3/4, we're going to write 0.75. And then we're going to add 3 plus 0.75 to get 3.75. Okay, next example. We are going to find the least common denominator for the following fractions. So we have 3 fractions, 5/8, 1/6, and 3/4. So we want to find the least common denominator, often abbreviated LCD, least common denominator. And we've actually already done this. This is the same thing as figuring out the least common multiple. So our goal is to look at the denominators and find the least common multiple. But since they are the denominators of fractions, we call it the least common denominator. And the way you do that is with prime factorization. 8 can factor into 2 times 4, and then 4 can factor into 2 times 2. So here's the prime factors of 8. 6 factors into 2 times 3, those are both prime. And 4 factors into 2 times 2, which are both prime. Now what we do is we go through all of the different factors and we pull out the greatest number. So this one has 2 2s, this one has 1 2, this one has 3 2s. So our least common denominator needs to have 3 2s. This one has no 3s, this one has a 3, this one has no 3s. So even though 2 of them don't have 3s, this one has the greatest number of 3s. It has 1, 3. So that needs to be in our least common denominator. 2 times 2 is 4, times 2 is 8, times 3 is 24. So there's our least common denominator. And the reason why you would want to do this oftentimes is because you would be adding or subtracting these fractions. So instead of having 5/8, we have something over 24. We had to multiply 8 by 3 to get 24, so we're going to have to multiply our numerator by 3 to get 15. 1/6, the denominator of 6, we would have to multiply by 4 to get 24. So we have to multiply our numerator of 1 by 4 to get 4. And then finally 3/4. To go from 4 to 24, you have to multiply by 6. So we're going to multiply our numerator of 3 by 6, and 3 times 6 is 18. Here are the fractions with their new denominators. They're all equivalent fractions. So 5/8 is equivalent to 15/24. 1/6 is equivalent to 4 over 24, and 3/4 is equivalent to 18/24. And again, the reason why you might want to do this is you might be asked to add all of these fractions together. And when you're adding fractions and subtracting fractions, they need to have the same denominator.